This is our first video for lesson 1, and we're going to focus in on the first triangle that we learned. So going from moles and particles by using Avogadro's number to convert between the two of them. We'll do another video to look at the molar mass triangle, but for now I've also made a third triangle because you'll notice that quite a few questions actually ask us about atoms. But when we use the Avogadro triangle, big N typically means molecules to us. So we'll come back to this third triangle to figure out how to convert between molecules and atoms. So the first question I decided to take from the mole conversions worksheet is number 5. What is the number of atoms in 1 mole of calcium carbonate? So the easiest one to find first is that we know how many moles we have. N is going to be 1 mole. We're trying to find the number of something within that mole. So we're finding big N. And we also know what we're working with. We're working with CaCO3. And when you see something like what number of atoms you're looking at how many atoms are within this molecule. So I just counted them out right from the get-go. I've got 1 Ca, 1 C, 3 Os. That means I have 5 total atoms in this molecule. Okay, so we know we're finding N. So we're doing moles times Avogadro. So that's our first step. We have 1 mole times Avogadro's number. Obviously the answer just ends up being 6.02 times 10 to the 23. We now know how many molecules of CaCO3 we have, but we want to know how many atoms are involved in that. So that's where this third triangle actually comes in. So we have the number of molecules, that's 6.02 times 10 to the 23 we just found, and we counted out that we have 5 atoms per molecule. So because these guys are side by side, to find out the number of atoms, we multiply these two values. So that's what we've done here. 6.02 times 10 to the 23 molecules multiplied by how many atoms per molecule we have. And that's where the 3.01 times 10 to 24 works out. Question 10 I chose because it's the exact reversal of number 5. In number 5, we started with moles and we were trying to find atoms. In number 10, we're going to start with the number of atoms and trying to find moles. So we're trying to find our N value. So if we start with the number of atoms, we're going to have to go to this triangle first. So we have the number of atoms. We'll need to see how many atoms are in each molecule in order to find how many molecules are present. So let's count out this number. We've got 2 NAs, 1 S, and 4 oxygens, so 7 atoms per molecule. So I'm going to use that third triangle and do 6.02 times 10 to the 23 atoms goes on top, divided by how many atoms are in each molecule, and we'll come out to 8.6 times 10 to the 22 molecules are present. So nice, I now have this N value. I can divide it by Avogadro's number in order to find N. So that's my second step. I've done the value we just found, divided it by Avogadro's number, and we'll come out to 0.143 moles in the end.